Hello, ladies and gentlemen. Welcome to today's video. Please help me to subscribe, share, and like my video. Today, we will go for the topic of chemical bond. So for this topic, we'll master these techniques, which include ionic bonds, covalent bond, giant covalent structure, and metallic bonds. We'll go one by one. First, we go to ionic bond. Ionic bond will happen only between metal and non-metal. The metal, they will lose electron and form cation. Non-metal will gain the electron and form anion. You'll always need to know all atoms actually they wish to become stable, octet or duplet. So that's why for group 1, 2, 3 and transition element, they prefer to lose electrons so they can achieve the octet or duplet. While for the non-metal, they prefer to gain electrons so that they can be in the stable state. So one part will be positive, one part will be negative, and the attraction forces between this opposite charge will form a very strong bond, which is the strong electrostatic forces. Just now we already know metal will lose electron and form cation. Non-metal will gain electron to form anion. But how many electrons will they lose or gain? You always need to bear in mind all atoms that wish to form octet or duplet, which is stable. For example, magnesium, it's 282. They have extra 2 outer shell electron. That's why they will lose 2 electrons and become 2 plus, Mg2 plus. And then how about, let's say, nitrogen? Nitrogen, 7 electrons, so it's 2, 5. To achieve stable electron arrangement, it need to have 8 full shell. So it need extra 3 more. It need to gain 3 electrons. So that's why all group 5 will be 3 negative. All group 7, it need 1 more electron. That's why it's 1 minus. Group 6 will be 2 minus. So this is how you know how many electrons they will lose or gain. So after you know them, let's say it's magnesium, I want to pair it with chlorine. So we know that chlorine is Cl negative. How will the compound form? So we can use this method. Mg is 2 plus, Cl is 1 minus. The compound must have a balanced charge. So I need to times here 2. So here will become 2 plus, here will become 2 minus. Then that charge is balanced. So we know Mg we only need 1, but Cl we need to have 2. So that's why the compound that will form is MgCl2. So next, let's see the properties of ionic bonds. Because it's very strong bond, which is the electrostatic forces between the positive ion and negative ion, this strong bond causes the melting point and boiling point is very high because we need a very high amount of energy to overcome the attraction forces. That's why the melting point and boiling point both very high. So next, we see about the electric conductivity. We need to know electric will only be conducted if there is something that is mobile, means they are freely moving. So in solid state for ionic bond, there is no mobile ion or electron because all the positive charge and negative charge structures are on a fixed position. That's why in solid ionic structures, they do not conduct electricity, but whenever they become liquid, either you heat them to the molten state or you dissolve them into water, the ion, the positive, negative ion, they can freely move. So because of this mobile ion, they can conduct electricity in liquid state. So let's see the past year question. First, they ask you the structure of sodium chloride. Sodium is metal and chloride is a non-metal, so they will form this. What is X and Y? So we know that is cation and anion or positive ion, negative ion. So next question asks, magnesium react with oxygen to form magnesium oxide. Magnesium is group 2, oxygen it's 2,6, so it's group 6. So group 2 and group 6, metal, non-metal, they will form ionic. So what happened to magnesium atoms and oxygen atom during the reaction? This magnesium, the electron structure is 282 because you have 12 electrons. So the first shell, 2 electrons, second shell, 8 electrons. So the balance 2 electrons on the outer shell. So to achieve the octet or duplet, they will lose 2 electrons. While for oxygen, it is initially 2,6, so it needs to gain 2 electrons, so they will become 2,8 also. So this is how they become Mg2 plus and O2 minus. So magnesium will lose 2 electrons. oxygen gain 2 electrons. Second question they ask, magnesium react with oxygen to form magnesium oxide. So we know that magnesium is a metal, oxygen is a non-metal, so they will form ionic bond. It's the magnesium first, so magnesium is group 2, which means they have 2 outer shell electrons, means they will lose the 2 electron, will from 2,8,2 become 2,8. So they lose 2 electron, form Mg2+. How about oxygen, which is 2,6, so they will gain 2 electron. Mg will become 2+, O will become 2-. So always remember metal, they will lose electron, and then non-metal, they will gain electron. So we see magnesium lose 2 electron and oxygen gain 2 electrons. So this thing you can refer back to the periodic table to double confirm how many electrons they will lose or gain. The next question that says, which statement about ions and ionic bond is correct? So we see A. They talk about bromine. Bromine atom form negative charge. So we know that bromine is group 7, non-metal. So non-metal, they will gain electron to form bromide ion, correct. Second, ionic bonds between group 7. No, group 7 is non-metal. Non-metal and non-metal will not form ionic bond. C. Positive ion are formed when atom lose proton. No. It can only lose or gain electron, never for proton, because proton is inside the nucleus. How can it involve in the reaction? D. Potassium iodide contain negatively charged potassium ion. Potassium is a metal. Metal will always positively charged, so also wrong. So for the next question, element X and Y react to form a compound. X lose 2 electrons, means that X is metal and it will form positive charge. Element Y gain 1 electron. So gain electron is non-metal. Gain 1 electron means it's 1 negative. How will be the formula looks like? So X will become 2+, Y will become negative. Here is 2 plus, is 1 minus, is not balanced yet. So that's why this part we need to times 2 to make it become 2 negative. And then here times back 1, it will become 2 plus. So at last we know X we only need 1, Y we need 2. So it's XY2. So it's B. Okay, next question, they already show you P comes from 1, 2, 3, 4, 5, 6, group 6, which they will gain 2 electrons so that they become stable. So P at last will become 2 negative situation. How about Q? Q is only 1 outer shell electron, so it's group 1, which is a metal that it will lose this 1 electron to form Q1+. So formula of the compound, P is 2 negative, Q is 1 positive. Then the 1 positive we need to times 2 so that it can be balanced, 2 negative, 2 positive. So we know it is P1, Q2. Next, let's try some paper 4 question. They say magnesium forms ionic compound. Magnesium reacts with fluorine to form ionic compound magnesium fluoride. The electron configurations are shown. So we know magnesium have 2 outer shell electrons, so it's group 2, and it will lose 2 electron and form Mg2+. Fluorine is 1, 2, 3, 4, 5, 6, 7, so it's group 7, so it need to gain 1 electron and form fluoride ion. So first thing they say is complete the dot and cross diagram in figure 3.2 to show the electronic configuration of 1 magnesium and 1 fluoride ion. So 1 magnesium, it will lose these 2 electrons. It will still have this 1, 2, 3, 4, 5, 6, 7, 8. And the outer shells, 2 electrons will lose to fluorine. Fluorine initially have 7 electrons. To be stable, they will receive 1 electron from magnesium. It will reach full outer shell electrons. So here I lose 2 electrons, will become 2 positive. Here I receive the negative electron, so it will become -1. Next question, they says, when solid magnesium fluoride dissolves in water, it will form a solution that conduct electricity. As we know, ionic do not conduct in solid, but conduct electricity in aqueous. And then state one other change that can make solid magnesium fluoride to allow it to conduct electricity. Other than dissolve in water, we can also heat until molten state. The next question is very similar to the previous question, but they do not give you the original structure of aluminium and fluorine. So we must refer back to periodic table. So they say aluminium will react with fluorine to form AlF3. Aluminium, initially the electron arrangement is 2, 8, 3. It will lose 3 electrons to form aluminium 3 plus. Fluorine initially is 2, 7. So it will gain 1 electron to form F minus. So they already tell you it is AlF3, very good. But if you want to form yourself, you also know how to form, right? So aluminium F, 3 plus, 1 minus. So here I need times 3 to make it 3 positive, 3 negative. That's why we know it's Al1F3. Okay, so the first question asks you to write the symbol equation for the reaction. Aluminium initially is Al. For group 7, always in diatomic situation, it will form aluminium F3. We do balancing. I'll do fluorine first. So fluorine here is 2, here is 3. So here I times 2, here I times 3. So both also 6. Balance, balance. Then we compare aluminium. So here the family already locked here. So I have 2 aluminium. So here we must follow. So it's 2. Next, they ask you to complete this figure to show the electronic configuration of aluminium and fluoride. So aluminium is 2H3 and lose 3 electron. It will left 2H. We must use back the cross as they're shown. Fluorine is 2,7, except 1 more electron. So I draw the original 7 first, or using back black dot. Must be obvious enough. And then 1 electron need to gain from aluminium. 1 cross here. Aluminium lose 3 electrons to become 3 plus. Fluorine gain 1 electron to form negative. Next question says potassium react with iodine. We know potassium is group 1, which is metal. Iodine is group 7, non-metal. So they will form ionic bond. So which statement about potassium iodide is correct? A. Each potassium ion share electron. No. For ionic metal and non-metal, one will lose, one will gain. So share is not an option. Next, in potassium iodide, the particles of potassium have more protons than electrons. Group 1, after they lose electron, of course, proton number will be 1 more than electron. So that's why we will have K positive. So here correct. C, they say potassium iodide have high melting point because of its covalent bond. No, it's not covalent compound, it's ionic compound. Potassium iodide have low melting point. No. Ionic compound is high melting point. Next, the melting point of sodium oxide is metal and non-metal. So it's ionic. Carbon and oxide is both non-metal. So it's covalent. So they give you the melting point is very, very different. So explain in terms of bonding why sodium oxide have high melting point. Explain based on the ionic bond. So we know that sodium will form a positive ion, oxide will form negative ion. So positive ion and negative ion form, they will have strong attraction force between them. So as long as you say it's about positive and negative ion, you can say it in cation and anion. Then you tell me you have strong attraction force, or more accurately, you can say strong electrostatic forces between them also can. Then you gain 2 marks. Next, we go to the properties of the ionic bond. So they say magnesium fluoride does not conduct electricity when it's solid. What can be done to solid magnesium fluoride to make it conduct electricity? In your answer, explain why magnesium fluoride conduct electricity when this change is made. So we know that in solid state, they don't have mobile ions or electrons. So that's why it cannot conduct electricity. So it's either dissolved in water or heat until molten. This question just requires you to write one method. So you just choose either one. And then the second point, it will have mobile ions. Next, talk about covalent bond. Covalent bond only between non-metal that will share electron and form molecule. So we have some very, very famous covalent structures. For example, oxygen. Oxygen and oxygen share electron. For example, nitrogen. CO2. So all the situation, they are sharing electron and form molecules. We go deeper in. So how will they share electron? So if there are lack of one electron to achieve the stable situation, they will share one electron and become one pair of electron sharing. If they lack two, they will share two pairs of electron. So for example, fluorine. Fluorine is 2,7. They need one more electron to achieve stable situation. So they will have 7, and then they need to share with another fluorine. 1, 2, 3, 4, 5, 6, 7. So can you see this X and O, they are sharing. So this fluorine also can achieve 2,8. This fluorine also they can achieve 2,8. How about oxygen? 2,6. So they want to share 2 electrons. After they share 2 electrons, they will have 4 more balance. 1, 2, 3, 4. The 2 will be sharing. For another oxygen also, 2 will use to share, left another 4. 1, 2, 3, 4. The other 2 will use to share. At last, both of them will achieve 2,8. So this is how they share. And also you need to know, throughout the whole covalent sharing, no mobile electron. Can you see all the electron is fixed position, no ion form? Because of no mobile electron, no mobile ion, so they are unable to conduct electricity in all states. Solid, liquid, gas, all they cannot conduct electricity. Next, we will learn about the properties of covalent element. For example, oxygen and oxygen just now, they are sharing, right? So this is one molecule. So when this simple molecule and another simple molecule, these two oxygen between them, what is the bond between them? There are some intermolecular forces, which is super weak. Of course, when you go to further level, you learn about van der Waals bond. It's the more scientific names, but now you just need to know the intermolecular bond between the molecules are weak. All covalent structures that will have low melting point and low boiling point. Then we can try to pass this question. First question, which diagram represents the outer shell electron arrangement is nitrogen molecules? So we know nitrogen is 7 electrons, so the arrangement is 2, 5. The lack of 3 electron means they need to share 3 electron for each nitrogen. So here, they only share 1 electron, which is no. Here, they share 2 electron, also no. Here 2, of course, no. Here 3, yes, because they lack of 3 electrons. Next question, which molecules contain only 3 share pairs? I need to see one by one. Carbon is 2, 4. They lack of 4, so they must share 4 electrons. It's more than 3 shared electrons, so we can directly reject here. Cl is 2, 8, 7, means each of them lack of 1 electron, so they will share 1 electron pair. Won't be 3. H2O, each H is very special because it's in the first shell. First shell, it can only fit in 2 electrons. So initially, it already have 1, so it lack of 1. And then oxygen, it is 2, 6, which means it lack of 2 electrons. So we know that you need to share 2 electrons because it's lack of 2. And then for hydrogen, it's lack of 1. At last, the shared pair is only 1 pair, 2 pairs, so it's not enough. Nitrogen is 2, 5. It's same as the previous question, 2, 5. So they lack of 3 electrons. So they need to share 3 pairs of electrons. So answer is donkey. So next question asks us to complete a dot and cross in the diagram of 3.3 to show the electronic configuration in a silicon tetrachloride. So refer to silicon. Silicon 14 electron, 2, 8, 4. It lack of 4 more electrons. So all 4 electrons need to share. Chlorine is 17 electron, 2, 8, 7, means each of them lack of 1 electron. So we have 1 electron share with others. So initially they have 7 electrons. 1 is used to share. It means that 6 is not sharing. So we just draw it. 1, 2, 3, 4, 5, 6. Same goes for others chlorine. Done. Next question. Nitrogen molecules have formula of N2. Some properties are shown. Melting point, boiling point, both negative means very, very low. and is non-conductor of electricity when solid. Actually, in liquid and gas also, it won't conduct because it's covalent. No mobile ion and electron. And then insoluble in water. So they ask you name the type of bonding between nitrogen. So it's non-metal, so it's covalent. Next, explain in terms of attraction forces between particles why nitrogen have low melting point. So nitrogen N2 itself is a molecule. So why low melting point? Because intermolecular force is weak. Explain why nitrogen does not conduct electricity, because no mobile ions or electrons. The next question looks hard, but actually is still very simple. They says carbonyl fluoride. If the thing that is not in our syllabus yet, they will show you the structure, which is CFFO. They say it's a covalent compound and then ask you to explain using your knowledge of structure and bonding why this thing has low melting point. So whenever we involve covalent structures, we always mention this and another molecule, the attraction forces between them are weak. So it just says weak intermolecular force. Why weak intermolecular forces will cause the melting point to be low? Because small amount of energy is needed to overcome the forces. Part 2 is simple covalent, which the sharing of electron is happen in a few or two atom only. But for giant covalent in part 3, there are many atoms sharing electron with each other. There are 3 things that we need to know, which is silicon, 4 oxides, diamond, and graphite. Let's have a look on 3D situation. Silicon oxide consists of 2 atoms, which is silicon, oxygen. So 1 silicon will bond to 2 oxygen, 1 oxygen will bond to 2 silicon. How about diamond? Diamond is fully formed by carbon only. Each carbon sharing electron with 4 carbon. And because of this infinity covalent structure, because of very hard. So that's why diamond can use as cutting tool. So after we see these, there's one very special structure called graphite. Graphite also consists of fully carbon, but each carbon can only bond to 3 carbon, which means carbon that need to share 4 electrons. 3 is bonding using covalent. 1 electron will form the mobile electron in layers. So because of this mobile electron, it can use as electrode, it can conduct electricity. And also, can you see it form a layer? So layer and layer, they can sliding over each other easily. That's why graphite also can use as lubricant. So can you see the first question is very easy. They say there are 3 macromolecule PQR. P, it consists of 2 types of atom. We can confirm as silicon oxide. Q is 1 type of atom and form a 3D structure, is confirmed diamond. R form layers, so it's graphite, so it's C. Next question asks you which know about properties about diamond and silicon oxide. First characteristic, they're asking for conduct of electricity. We know only graphite can conduct electricity. And then the type of molecule, we know giant covalent will learn 3 diamond, silicon, 4 oxides, and also graphite. So it's C. Next question, compare diamond and graphite. They say which statements is correct. So diamond and graphite are both pure carbon, correct? They are both macromolecules, correct? Diamond and graphite can both be used as electrode? No. Diamond cannot be electrode because it can't conduct electricity. Only graphite have mobile electrons, so it can be electrode. So graphite is also used as lubricant, yes, because it forms layers. Diamond has covalent bonds, yes. Graphite has ionic bond, no. Both have covalent. Diamond is hard with high melting point, yes. Graphite is soft and have a low melting point. Okay, graphite solid in room condition and it's actually quite hard for boiling it. So that's why it's still high melting point. Next, about graphite. Graphite has giant covalent structure. Which statement about graphite are correct? Carbon atom form 4 covalent bond. No. 4 covalent bonds, then it will form diamond. It's only 3 covalent bonds. There are delocalized electron. Yes, delocalized, mobile, free moving is the same meaning. So graphite is useful lubricant. Yes. Graphite is a good conductor of electricity. Yes. So it's 234. We try a paper 4 question. They say diamond and graphite are different solids forms of carbon. The carbon atom in diamond and graphite are arranged in different way. State the number of covalent bond each carbon atoms in diamond. 4 covalent bond. For graphite is 3. State the term used to describe the structure of diamond, giant covalent. Name an oxide that have similar structures to diamond. We have 3 giant structures. 2 things that will form 3D shapes as diamond and also silicon 4 oxide. Next, describe the arrangement of atom in graphite. The arrangements form layers, and then it will form hexagon ring of carbon. And then explain how graphite conduct electricity because of the mobile electron. Last bonding is the metallic bond. Metallic bond for metal themselves, they do not gain electron, they do not lose electron, they do not share electron. Let's say sodium atom, when they arrange together, the outer shell electron, they will come out and form electron C, and then the sodium atom will form positive ion. So all metal have this structure, positive ions and a C of mobile electron. This positive charge and negative charge because they have a very strong electrostatic forces. That's why all metals have high melting point and boiling point. Other than that, because of this freely moving electron, the C of electron, no matter it's in solid, liquid, they can conduct electricity. And then all the positive charge ion, they form a layer. When I push them between the layer of ion, they can slide over each other. Because of this special characteristic, there's one very important term, we call them malleable, which means they can easily change shape. So that's why all metal, we can mold them into different shape, or we can hammer them into different shape. So whenever they say malleable, you need to think about the shape can change. Other than this, we also have ductile, which they can pull into a fine wire. Let's see the question. Which particle are present in the structure of metal? We know that it to form positive ion and electron C. So positive ion, yes, they don't have negative ions. It only have the mobile electrons. So 1, 4. Next, which Joule explains why copper is a good conductor of electricity? So all metal is good conductor because they have free moving electron. Yes, positive ion actually fixed there. Just the C of electron can freely flow. So it's B. Next, which Joule describe the structures of solid metal and explains its property? It's a lattice of positive ion with C of electron. It can conduct electricity because ions are free to move. No, it's the electron free to move. It's malleable because the layers of ion can slide over each other. Yes, that's why it can change into different shape. Next question asking, transition element and group 1 elements are metal. More details can go back to periodic table video. They share many physical properties including conduct electricity and hammer into shape. Explain why transition element and group 1 elements conduct electricity. We know both of them are metallic bond, so mobile electron. Don't talk about ion because in solid state, the positive ion is in fixed position. Only the C of electron can freely move. Next, state a property that describes a material which can hammer into shape. So when think about metal and they can change shape, it's confirmed malleable. Next question, describe the bonding in metallic elements such as beryllium. See from the periodic table with 2, 2. The outer shell electron will form the electron C. This is how the metallic bond structure show. So after you draw this, you also need to describe the bonding. So the bonding is between the positive ion and mobile electron. Is attracted strongly. Next, they say explain why metallic elements such as beryllium are good conductors of electricity. We already successfully do all 4 types of chemical bond. So we finished the chemical bonding chapter, and don't forget to subscribe, like, and share my video. If you have any questions, please feel free to comment here. So see you in the next session. Bye-bye.